In this video we're going to look at drawing a parabola, and the method that we have for doing a parabola is the rectangle method. So this comes up at the higher level of the ellipse question. So we're just going to have a look at how we set that up. At the moment I have a rectangle. This rectangle is 100 tall and it is 90 wide, and this is my axis splitting the center of the rectangle. So it's 100 tall and it is 90 wide. The axis then halfway, 45 millimeters. So we are going to draw a parabola, and I want my vertex, the top of the parabola, to be up here at V. So up here at the very top. So what I need to do is I need to draw my curve. So my curve is going to go up along this way here somewhere, coming across the top and back down here on the opposite side. Before I move on, I found my vertex. Now I'm going to label my 0 points. So these are the ones that are furthest away from it. So it's not going to be this one or this one. It's the diagonal furthest point away. They're my zeros. If you can locate your zeros, the rest of this becomes a little bit easier. So what I'm going to do is I'm going to take each half of the rectangle separately. So I'm going to take the left half of this first, and then I can worry about the right hand side of it afterwards. For my rectangle method, I need to divide the sides, so this side and this side as far as the axis only, up into the same number of equal parts. So if this is 100 tall, this is 95 or 45, I can divide this up into 5 equal parts. So if I do 5 equal parts here, each section is 20 millimeters, and label them 1 to 5. So we already have 0. So this is 1, 2, 3, 4, 5 being the top point. Across here I'm going to do the same thing. I'm going to divide this up into 5 equal parts. It must be the same number of equal parts as you had on this side. So if you had 4 here, you must have 4 here. If you have 7 here, you must have 7 here. 45 divided by 5 gives me 9. So if I divide this up, I'll just mark off 5 sections here, all 9 millimeters long. So again, label these, so 1, 2, 3, and 4. Now, this is the bit that catches most people when they're drawing it. If I take the ones that are parallel to the axis, so these ones here, the lines are parallel to the axis, they need to join to the vertex. So parallel to the axis joins to the vertex. Parallel to the axis joins to the vertex. So 4, so each one here on the side of the rectangle that's parallel to the axis joins to the vertex. Now this is where the confusion comes into it. On the side that is perpendicular to the axis, they must be drawn parallel to the axis. So these ones here, they come out, they're on the line that intersects with the axis. They need to come and be drawn parallel to the axis. This is where our confusion arises. So the ones that intersect the bottom edge of the rectangle, the ones that intersect the axis, need to be drawn parallel to the axis. And each point where each of the 1s, 2s, 3s, and 4s intersect each other is a point on my curve. So this is 1, 2, 3, and 4. 0 is also a point on the curve. So we're going to join all of these up, best curve that we can. Giving me the parabola on the left hand side of this. To do the right hand side of this, you can do the same thing. So you can divide this here and here up into the same number of equal parts, or you can just do an axial symmetry and take each point perpendicular to our axis. So as to take point 2 here perpendicular to the axis. Its distance is going to be the same on the opposite side of the axis. So from our axis to the point, same distance on the opposite side. That's point 2 2, this point 2, 3, and 4. So copy the distance, mark it on the opposite side, set up my compass for distance to 3, same on the opposite side, and do the same thing for 4. And then draw the curve as best you can, join up each of the points up to the vertex. And there we have our parabola. So just a quick recap. You need to divide the sides up into the same number of equal parts. If they don't divide in evenly, use the construction for dividing a line. So dividing the line up into the same number of equal parts. On the edge of the rectangle that intersects the vertex, you're going to go parallel to the axis. Sorry, the edge of the rectangle that intersects the axis, you go parallel to it, and the ones that are already parallel to it, you join to the vertex. So that's the first part of this. Now we're just going to look at a parabola drawn at an angle, just to show that the principles are the exact same. So my side lengths here are slightly different. So the side length of this is 110, and the side length across the bottom is 40. Or the overall length is 80, but half it is 40. So I'm going to divide this up into 4 equal parts. So labeling my zeros first, then 1, 2, 3, and 4. Can divide the side here up into 4 equal parts as well. So 110 does not divide evenly by 4. So I need to have to draw a line off at an angle. If you used 5 in this case, it would have worked, but just to show how you draw it. So line off at any angle, mark off 4 sections of equal length, 1, 2, 3, and 4. Join the 4th point back to O, back to the end of my line that I'm bisecting, and I'm going to take all my points and my lines parallel to that line now. So parallel back along, just until they touch the line, don't go through the line. So that gives me my 4 points. 0, 1, 2, 3, 4 being up on top. So now we're going to follow the same principles that we did for the previous one, for the previous question. On the ones that are on the side of the rectangle that is intersected by the axis. So these down here, they are drawn parallel to the axis. So these lines came from the side that is intersected by the axis. So here, this side, they are drawn parallel to the axis. The other ones then, the sides that are already parallel to the axis, they join to the vertex. But if you can get one of them right, then you'll get the second one right. So that gives us our 3 lines where the 1's cross, 2's cross, and 3's cross. And we're going to draw our curve as best we can. So it goes through each of the points, back down to 0. The opposite side of this is done the same way. You can do this method, or we can just do the method that we just looked at previously, where you use an axial symmetry. So lines perpendicular to the axis. Measure this distance, same distance on the opposite side.